Today's goal, we want to be able to identify a function by its graph. Identify functions by their graphs. Now, this lesson, you'll notice there's a PDF file at the top of this lesson with a worksheet that you can print out for your notes. Listen, I highly encourage you to print this out if you can. If you can't print, if you don't have a printer, then get out a scrap sheet of paper and work these problems out by hand. Listen, what we're going to do today, yeah, you could sit here and watch me do this, but it's so hard to learn this by just watching. This is really an assignment. You need to dig in with your hands, get your hands dirty, and you can just feel these functions being created so much better if you do it by hand. And I'd like you to try these problems on your own first. Let's slide down to example number 2 as an example. Here's how we would do this by hand. We're asked to graph this function. We're just going to start plugging these x values into the function. So if I do 0 minus 3 in parentheses squared minus 1, I get a value of 8. Okay, so I'm going to put an 8 in the table here. And then I'm going to do the same. I'm going to put a 1 in place of the x. I get a 3. I'm going to continue. I'm going to put a 2, a 3, a 4. If I plug a 2 in for x, there's what I get. If I plug a 3 in for x, I get a negative 1. If I plug a 4 in for x, I get a 0. You get the idea. So there is the completed table. And then what I'm going to ask you to do, I want you to start plotting these points. So we have this point 0, 8, 1, 3, 2, 0, 3, negative 1, 4, 0, 5, 3, 6, 8. Okay, and after you've plotted these points, now I want you to consider, what type of shape do I have here? This is clearly not a straight line. You can see that these points are going to cause a bend or a curve. Now, maybe you know what this shape is called. Maybe you've forgotten. I'm sure you've learned in Algebra 2 what this is called. But just connect the dots as best as you can to get a sense for what kind of shape these points make. Now, for right now, I don't want you to worry about filling in. You don't need to worry about the domain, the range, the vertex form, the name of the function, the description. We'll fill that out in a little bit. Right now, just try completing these tables on this worksheet. Okay, and I know it continues. Here's examples 3 and 4. I think it goes all the way up to number 7. Do the best you can, and then I'll come back with the descriptions and the type of functions here in a little bit. I do want to give you one quick note. You will get an occasional error in your calculator while you try to do this. So like on example number 4, if I plug in a negative 6 into the square root, it'd be the square root of negative 6 plus 4. I'm going to get an error in my calculator. If that ever happens, you can literally just write the word error here, and you'll kind of skip that point. But you'll find the rest of these points will have solutions that you'll be able to graph. And if you do ever get a decimal, if you do ever get a decimal on these, you can round it to just round it to like 2 or 3 decimal points, and just estimate as best you can where that would fall on the graph. So at this time, I'm gonna have you try this on your own. Go ahead and hit pause on your video. When you come back, we'll fill out the rest of this information for the notes. So here on your screen is example number 1. Here are all of your points. I think this one was very easy to figure out. When you put all these points together, they make a perfectly straight line. And so example number 1 is actually called a linear function. Go ahead and write this in your notes. It's called a linear function. The graph makes a straight line, and the thing that makes a function linear is if there's no exponents with the x. This x is all here by itself. It's not to any powers. It does not have a square root, nor is it in the bottom of a fraction. The domain of linear functions, of this linear function, would be all real numbers. as well as the range. And then write down this general form right here. This is very important. The general form of a line we say is mx plus b. So feel free to pause if you need to get all that written down, but go ahead and write that in your notes. Now, example number 2, we kind of started doing this one by hand. Here's what the points look like. The name of this graph, this actually is called a parabola. Parabola is always curving. Here I am trying to connect these points as best I can. I know it's a little sloppy. A lot of people think a parabola is like a U shape, and I put little arrows on the end here. Now, the shape of the graph is called a parabola, but the function itself is called a quadratic function. And the key with the quadratic function is that the x is being squared. Now here, the x isn't directly being squared, but the x is in a parentheses with a square outside of the parentheses. That's what makes it quadratic. Now, this particular quadratic function, the domain is all real numbers. You have arrows on the left and arrows on the right. But the range would be from -1 to infinity because it does have a low point. And I'm going to point this out real quick. This low point is called a vertex. So this point right here is called the vertex of the parabola. And then go ahead and write down this form. This is called the vertex form of a quadratic function. All right, now example number 3 is when it gets kind of gets a little goofy looking here. When you plot these points, you see they kind of scatter all over. There's no symmetry to these points at all. You'll notice that this function has an x to the third in it. So this type of function is called a cubic function because the x is cubed or to the third power. And what happens with the cubic function doesn't just have a vertex like a quadratic function. It actually has kind of like two vertices. They're called turning points. And this graph may or may not be perfect, but you get the general idea. It kind of makes like an N shape. Or it's almost like, it's almost like having kind of two curves put together. You have these two turning points called the relative maxima, which is here, and the relative minima, which is here. So again, make sure you write down the general form of this, the cubic function. Example number 4, let me change my view here. Let me zoom out a little bit so you can see better. So example number 4, you'll notice the x is inside of a square root. This is called a square root function. And so here are my points kind of plotted separately. With the square root function, when you connect these points, what happens is you actually get a sideways parabola. But then the funny thing is you only get half of it. You only get like the upper half of that parabola. So I like to say the square root function, you get half of a sideways parabola. It'll have a starting point here, but there'll be nothing to the left of it. Notice we got an error. Any number, any x value less than -4, you're going to get an error because the graph doesn't go over here. It doesn't exist in any domain less than -4. That's why the domain of this graph is from -4 to infinity. The range would be from 0 to infinity. And again, very important, make sure you write down this general form of the square root function. All right, next, let me zoom back in here. Well, I'm just going to leave it like this. So you'll notice this time the x of our function is in what's called an absolute value symbols. And real quick, the way an absolute value works, if I were to plug a -3 in for x, what I would do is I'd work out the inside of the absolute value. I would do -3 minus 3 is -6. But the absolute value takes any negative answer and it turns it into a positive answer. And so, so that's why these outputs are all positive. Now, what does that cause on a graph? It actually is going to make like a V shape. It's going to make a graph where everything is going to be above the x-axis. And so it makes this V shape. This is known as the absolute value function. And you can see the domain and range here. Go ahead and make sure you write down this general form of the absolute value function right here. Absolute value function makes the V shape. All right. Example number 6. Now this time, if you look at your x, our x is in the denominator of a fraction. Okay, and what we call this a rational function. Now, the word rational, a rational number is any number that can be written as a fraction. A lot of times I'll tell students to help them remember the word rational kind of sounds like the word fractional. And so rational functions happen anytime the x is in the denominator of a fraction. Now, this is going to be undefined at 0, okay? There's a rule in math, you can't divide anything by 0. You'll get an error on your calculator. If you try to do 10 divided by 0, it comes out as an error. So what does this graph look like? We see all these separate points. The graph of a rational function actually makes two separate curves. And they're similar to a parabola, but not, I would generally say they're not as, oh, I messed that up. I would generally say they're not as steep as a parabola, but it is kind of similar. But there's two of them, okay? So here we have one on the right-hand side. Let me draw it this way, it's a little easier. And you're going to have a matching curve on the bottom left-hand side. And the two of these curves put together, they make kind of an hourglass shape a little bit. It's called a hyperbola. A hyperbola is this double curve, kind of put them together and you get this hourglass shape called a hyperbola. Now, what's weird about a hyperbola, I could go on for a while about this and I won't. Hyperbola has something called an asymptote. And this curve is actually going to get infinitely closer to your x-axis and your y-axis, but it's never going to touch it. Okay, if I could zoom this graph out, you're going to see this curve getting closer and closer and closer and closer to our axes, our x-axis and y-axis, without ever being able to touch it. It actually gets infinitely closer to the axes without being able to touch. And I'll end it there because I could go on about that. And then our last one, example number 7, I should have forewarned you. I wanted you to graph, example number 7, I wanted your calculator to be in radian mode when you did this. And so if your decimals look a lot different than mine, that's why. I should have put that on the notes. I apologize. If we have our calculator in radian mode, these are the answers that we get. And you'll see kind of this pattern going on here. But the points do kind of go up and down. What this is called, here the x is inside of a sine function. This is called a sine function. You can also call it a periodic function. It's actually going to create a wave that repeats every 2 pi radians. It repeats itself every 6.28 on the x-axis. So what that looks like, and this wave is going to go up at its highest, it's going to go up to 1, and at its lowest, it's going to go down to -1. So here's my curve. And this is not perfect. I'm trying to do this the best that I can. Oh, I'm not supposed to go over 1. But this curve is called the sine wave. Generally, I can draw this a lot better. Generally, the sine wave looks like this. Okay, that would be called one sine wave. So make sure you write down the general form. And again, the sine wave, as it's written now, it never goes below -1 and it never goes above +1. That's why the range is as it is. But the domain, it goes forever to the left and forever to its right. It just completes, it continues just going in this wave over and over and over. All right, so with that in mind, best of luck to you on your assignment. Let me know if you have any questions. Bye.